So let's look at question number 5. In question number 5, we are told that in a siren, sound is produced when a jet of air is directed perpendicular to a ring of holes on a rotating wheel. Explain the effect on the pitch of sound produced when the speed of rotation of the wheel is increased. Now, what is a siren? Over here in your course book, you've got this literature here. They've shown you the siren. It is actually, it consists of this disc. It's got a number of holes. Some of them are far away from the center. Some of them, they are near the center. Some of them are wider. Others are very thin. And then there is a jet of air which is directed to these holes there. When this jet of air is interrupted, sound is produced. And you find that it is produced each and every time the jet of air is interrupted. It's more like when you get a test tube and you blow across the test tube. Sound is getting interrupted at the hole of the test tube. So the pitch of the sound produced by this siren is such that it varies with the speed of rotation of the disc, and at the same time it can also vary if the jet is moved towards the inside or towards the outside, because the speed of interruption of the jet of air varies. So we are asked, how will the pitch of the sound change if the speed of rotation is increased? So in the textbook, we are told that a siren in form of a disc with a ring of equally spaced holes which are equidistant from the center is used in this case. When it is rotated at a constant rate and air blown through the holes as shown in figure 9.6, sound of a given note is heard. The disc may have concentric sets of holes about its axis to vary the frequency. The disc may have concentric set of holes about its axis. So you can see these are fewer number of holes, while on the outside we've got more holes. The speed with which the air is interrupted increases as you move towards the outside. So that is one of the ways in which you can vary the frequency. Another way in which you can vary the frequency is by changing the speed of rotation. And that is what this question is about. Sound is produced when a jet of air is directed perpendicular to a ring of holes on a rotating wheel. Explain the effect on the pitch of sound produced when the speed of rotation of the wheel is increased. So here we are varying the pitch not by moving the jet of air, but by changing the speed of rotation of the wheel. So this is what is going to happen. The holes interrupt the jet of air more frequently when the speed of rotation is increased. The sound produced will therefore have a high frequency, hence high pitch. In sound, the physical quantity which is represented by pitch is frequency. So you must mention frequency. The frequency at which the air jet is interrupted rises, and that means the pitch of the sound changes. And that's all about question number 5. Let's go to question number 6.